morning friends, welcome back to your favorite channel Code One Digest. Today in this video we will learn the decompose by transaction design pattern. We will see the real world example of this pattern. We'll also discuss the use cases of this design pattern. Later at the end we will see the benefit of this pattern. Friends, in the previous video we discussed about decompose by subdomain design pattern. Can you explain what is decompose by subdomain design pattern? Kindly provide your answer in the comment section of this video. And if you have not seen that video, so please go and watch that video. The link is provided on your screen and also in the description section of this video. Just to recall, what is decompose by subdomain design pattern says. This pattern says define a services corresponding to your domain driven design subdomains. For more information, go and watch the previous video on Code One Digest channel. Friends, so here is the agenda of this video. I'll give you the introduction of decompose by transaction design pattern. Then we'll see a real world example of this pattern. Then I'll show you the use cases of this design pattern. We also understand the benefit of this design pattern. And then I'll summarize what we learned in this video. Then briefly we'll touch upon the next design pattern, that is Strangler design pattern. So stay tuned till end of this video. It is going to be exciting and there is a lot of learning in this video.
Friends, before we proceed in this video, I want you to subscribe my channel to grow Code One Digest family. Friends, I'm creating a lot of quality contents for you, but I'm not getting subscribers. I want you to like, share and subscribe my channel so that I can grow Code One Digest family. Thank you.
All right, let's get started.
So friend, before we start with decompose by transaction design pattern, let's understand what is monolithic and distributed transactions. When microservice architecture decomposes a monolithic system into a self-encapsulated services, it can break transactions. This means a local transaction in monolithic system is now distributed into multiple services that will be called in a sequence. Here, if you see in this example with a monolithic system using a local transactions, in the customer order example, if a user sends put order action to the monolithic system, the system will create a local database transaction that works over multiple database tables. If any step fails, the transaction can roll back. This is known as ACID operation. That means atomicity, consistency, isolation, and durability, which is guaranteed by the database system. So now, when we decompose that monolithic application into microservice architecture, into various microservices, so we created both the customer microservice and order microservices. We have separate databases. Here is the customer order example with the microservices. When a put order request comes from a user, both microservices will be called to apply changes into their own databases. Because the transaction is now across the multiple databases, it is now considered a distributed transaction. So the problem is, how do we keep the transaction atomic in distributed system? In a database system, atomicity means that in a transaction either all the steps completes or no steps completes. The microservice based system does not have a global transaction coordinator by default. In this example, if create order method fails, how do we roll back the changes we applied by the customer microservices? The possible solution to this problem would be the two-phase commit pattern or saga pattern. We will discuss this design pattern in detail with the database design patterns. But if we decompose our monolithic application in such a way that components participating in a transaction are the part of same microservice and there will not be any distributed transactions and there will not be any need to handle it. So the crux is, if we decompose our monolithic application such a way that all the component participating in a transaction must be part of same service.
Wow, that's amazing.
Okay friends, so now let's start with decompose by transaction design pattern. Microservice architecture has become very popular, one common problem is how to manage distributed transaction across the multiple microservices. Group your microservices based on transaction to avoid latency issue and two-phase commit problem. In distributed system, an application typically need to call multiple microservices to complete one business transaction. To avoid latency issue or two-phase commit problem, you can group your microservices based on transaction. So you can group your microservices based on transaction. This pattern is appropriate if you consider response time important and your different module do not create a monolithic after you package them. Okay friends, so let's understand this design pattern with an example. In this example, the insurance monolithic is broken down into multiple microservices based on transactions. In an insurance system, a claim request is typically tagged to a customer after it is submitted. This means that a claim service cannot exist without a customer microservice. Sales and customer are packed together in a one microservice package, and a business transaction requires coordinating with both of them. Now let's understand this design pattern with another example. In this example, we have customer order. If a user sends a put order action to a monolithic system, the system will create a local database transaction that works over multiple database tables. If any step fails, the transaction can roll back. This is known as ACID, that is atomicity, consistency, isolation, durability, which is guaranteed by the database system. But when we decompose the system, we created both the consumer microservice and order microservice, which have separate databases. And when we put order request, both the microservices will be called to apply changes in their own databases. Because the transaction is now across the multiple databases, it is now considered as a distributed transaction. But this will create a problem of data atomicity. In a monolithic system, we have a database system to ensure acidity. Hence, to avoid this problem, decompose a monolithic application such that components participating in a transaction are part of the same microservice package so that there will not be any need of distributed transaction handling. Okay friends, now let's understand the use of this design pattern. Use this design pattern to break monolithic application to various microservices. Use this pattern to avoid problem of distributed transactions. Use this pattern to achieve data acidity and atomicity. Now let's understand the advantage of this design pattern. This design pattern offers faster response time. Using this design pattern, you need not to worry about data consistency. This design pattern improves the availability and we don't need to worry about distributed transaction using this pattern. Okay friends, now let me summarize what we learned in this video today. I gave you introduction of decompose by transaction design pattern. Then I'll give you real world examples of this design pattern. Then I shown you the use cases of this design pattern. We also understood the advantages of this design pattern. So friends, let me know if you have already used this design pattern in your project or seen a scenario where this pattern can be very useful. Please provide your answer in the comment section of this video. Friends, in the next video, we'll discuss about Strangler design pattern. I'll show you what is a Strangler design pattern. Then we'll discuss the real world example of a Strangler design pattern. We'll understand the use cases of Strangler design pattern and we'll also understand the benefits of Strangler design pattern. So stay tuned for the next video and do subscribe to the channel if you are new to the channel to grow Code One Digest family. Thank you. Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners, and software engineers. I am putting a lot of efforts in creating these contents, so please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.